Good morning. My name is Kaushik, and today my topic in soft computing is about fire detection and control system in automobiles. So, coming to the introduction, despite the immense benefits of fire detection in road transport, it is more than 2,000 vehicles are damaged by unexpected fires on a daily basis, which is on a global scale. It is incidentally based losses for the automobile and insurance industries, which have run into the billions of dollars in the past decade. One contributing factor is the lack of sophisticated fire system in automobiles. So this has been addressed by designing and implementing fuzzy logic control system with feedback over an Arduino microcontroller system. So this automatic system, which contains flame temperature and smoke detectors, as well as re-engineered mobile carbon dioxide air conditioning unit, which was tested on a medium-sized physical car. So fire prevention, minimization, and suppression have been employed to address the problems of fire outbreak in automobiles and transportation in general. The fire prevention deals with using efficient, effective design principles to curb operational interferences that may lead to a fire outbreak, and it involves, which is not only limited to the choice of materials, materials geometry, and form of orientation in relation to other materials. The fire minimization is employing fire resistant materials in locations where there is a likelihood of fire propagation. Most automobiles have fire-resistant material serving as a firewall to protect the passenger compartment from engine compartment fire. So these firewalls are now perforated with openings for the flow of pipes, cables, and wires, which is not seen in older automobiles. Fire suppression systems, which aim to extinguish active fires, require, require some form of contact with the fire to be more effective. So the engine compartment fires sometimes damage the bonnet locking mechanism, making fire suppression more difficult in automobiles. So this is the design methodology where the source of fire can be in chassis, transmission, or engine. So the fire detection network consists of a flame sensor, temperature sensor, and smoke sensor. So the location of the fire detection can be uh, can be pro- can be used by probability through machine learning, and the equipment is used is CO2 gas or nozzles, and the data fusion required for fire detection network is used, which is fuzzy logic. So the fire control module, which is in fire location detection, contains microcontrollers, analog digital converters, digital analog converters, signal conditioners, and communication chips. And the control action is the compression motorized valves. So these are the flow chart for the fire detection and location. And so this is the flow chart for the whole integrated systems, first part of diagram, and the second part is and the second part of the diagram. So the design. Two fire detection networks connect to a single CO2 extinguisher backbone and a CO2 release network services the fire detection subsystems by responding to instructions from an Arduino Mega 2560R3 board. Each fire detection subsystem contains two sets of fire monitors that scan two or four zones around the vehicle continuously for fire signatures. The fire signatures in question are smoke, the temperature changes, and flames. Depending on the ambient characteristics, temperature sensors picked for the engine compartment and exhaust gas circulation zones were distinct from those selected for the passenger and boot compartments. So the functional and non-functional requirements are sensors should continuously monitor four zones around the vehicle chassis for fire signatures. When fire pertinence probability exceeds 30%, the horn should sound and hazard lights should flash. So when the fire probability exceeds 60%, the system should start and run the engine for 10 seconds, establish the fire's location, and turn on the air conditioner compressor. When the fire location is determined, the system should wait for 10 seconds and then open the location service valve. The system will then release CO2 within 20 seconds of fire detection. The system should report the fire location, status of service valve, the availability of the extinguisher was maintained at 99%. So the development tools we used are the system. So these are categorized as hardware and software. The fuzzy logic control system is designed using MATLAB and implemented in Arduino 1.6.0, and the system design was simulated using an ISIS professional with a with Porteous value stream mapping software. The hardware components include Arduino Mega 2560R3 board with its USB cord, infrared flame sensors, LM35 temperature sensors, MQ2 smoke sensors, copper wires, and 4 solenoid valves. The AC to DC power supply adapters serve the Arduino board with 3 breadboards, UTP cables, jumper cables, transistors, resistors, diodes, LED, liquid crystal beam screen, and a 5V DC motor. So the testing and the system implementation. The automobile's fire detection and control system was installed on a model car suitable for 3 to 7-year-olds. The cabin boot fire detection subsystem was first installed. An LED and a buzzer were introduced to indicate the presence of air conditioner and car horn, respectively. These were directly powered by an Arduino board through digital pins 24 and 30. Because the car operated on a 6V battery, an additional 12V battery was used to power the 2 extinguisher valves serving the passenger and boot compartments. So these are the images where the fire is detected in the passenger cabin, the car horn and hazard lights which are turned on. And the figure 15 contains the AC conditioner turns on and runs for 10 seconds. And the third 14 figure is the engine starts and runs for 10 seconds. And the last figure is the fire in the passenger cabin is extinguished after 20 seconds. So coming to the conclusion, the traditional electric cars are powered by thousands of battery cells that can overheat, catch fire, and explode, therefore ensuring that fire outbreaks do not result in fatal consequences will greatly increase road transportation safely. The algorithms that are derived from sound reasoning ideas have been implemented and tested using fuzzy logic technology embedded on Arduino board. Automobile fires have been detected and extinguished effectively without the driver's intervention and are without false alarms based on current testing. This multi-sensor fire detection and control is a useful, low-cost, sophisticated system which can also be tested and deployed on other systems in which air conditioners have been installed. Thank you.